All right. All right. Good morning. All right, clap once if you can hear my voice. Clap twice if you can hear my voice. Great. Oh, man, we got some sleepy hands, sleepy claps this morning. What is going on? Let's get ready. So I posted an optional warm-up for those of you who do not care about these review sessions, if you feel solid, totally fine. However, if you don't feel totally solid on your JavaScript fundamentals and stuff, let's do the warm-up. We got to remember that we do start every day at 10. I know I'm sure maybe I should do this announcement at 10 minutes. But if we're late, if the trains are late every day, that's not the trains. Okay? All right, so let's start here. This is the first problem I want you guys to start working on. And it's to write a function that takes in a starting number and an ending number. It should return the output. It should output the sum of all the numbers in between, including those numbers. So what's that going to look like? If I write sum and I write 5 and 10, I would have 5 plus 6 is 11, plus 7 is 18, plus 8 is 26, plus 9 is 35, plus 10 is 45. Okay? And you have 10 minutes. And then we'll keep going because I don't want this to go all the way to lunch. Yeah. Let's go. Oh, okay. I mean, I'll post this at the end. Necessarily. All right. Clap your hands if you can hear my voice. Lucky us. All right. So, how'd we do on this? Yay, nay, okay. Okay, mostly yays, a couple of okays, and a couple people without thumbs. So, why did I give you guys this problem? Well, it was kind of to prove the point that we don't always have an array, and we don't always need an array. So yesterday, all of our problems were we didn't start with an array, but we ended with an array. So we were creating this extra array to shove stuff into, and I saw quite a few people doing that. They started this problem with the same thing. So every time we approach a problem, we have to think like, what's the input? What's the output? What do we really need to do to get that? This problem, we definitely don't need an array. We've got all the numbers we need right here, but we're going to need some sort of loop potentially. I mean, there's a mathematical formula you could probably do too, where you just do like 5 plus 10 is 15, and you know every number in between is 15. But you know what I'm talking about, right? Well, 6 plus 9 is 15. 7 plus 8 is 15. So you could do like some sort of math and probably just instantly get it. I don't know the formula off the top of my head. Something like, but that's not really why. I wasn't expecting anyone to come up with just a math answer, although that would be constant times. That's technically a better answer. But let's get what we were actually just trying to practice. Yeah, sure. Well, I have to look up a formula for it, but we could. I mean, I can try to derive it. I'll do it during the next one. How's that? Okay, so we're writing a function. How do we start? Yeah, okay. So we're going to say function, and we're going to take in a start and an end to our range. And now we're going to be doing math. Sorry? Oh, that's a good idea. We can name the function. Otherwise, it's just an anonymous function. Good point. Thank you. So we should all be jumping in if I make that mistake. Thank you for being awake. Okay. Apparently, I'm not as awake yet. So I'm also not looking at what I'm typing. So it's kind of confusing. Okay. So we've got our function. We got our start and end. We probably need to do something. Since we're adding things over and over again, we should have some sort of like base. What do you think, Chris? Yeah, that sounds like a great idea. So he says, hey, let's set a variable of total. So I'll say like let total equals 0. And he's saying in this way, with every single number, I can just add it to the total, as I think that's what you're implying. And 0 is a good thing to add to because anything plus 0 is anything, right? So we go, all right, that's fair. That's a fair statement. So what are we going to do next? Michelle? That's right. So let's do some sort of for loop. First thing in the for loop is our starting point. So where do we want to start? At start? Yeah, okay, that sounds good. Let I equal start. Our ending condition, when should we end? Yeah, so we want this to, I guess it's ending condition, but it's really like written in the terms of like while, right? So it's like, so we're saying while I is less than or equal to our end. What makes sense for a step towards the end condition? I plus plus, right? Because we want to hit every single number. So I'm just going to do it like really, just to drill in what's going on under the hood. Okay, so now we're here. We've got our I, we've got our total. What do we need to do? What can we do? What can we do? Someone who I haven't heard yet from. Kelly. Yeah, that sounds great. So we can reassign the value of total each time to be itself plus the value of I. So we're going to do that, and then what's next? What do we got to do next? Yep, we got to return. And what do we want to return? Total, right? Okay, let's try it out. Sum of 5 and 10, 45. Bada bing! Yeah, we got it. Not too bad. Any questions on that and how we got that? Sorry? Oh, because this is ES5. When we write a function in ES5, we have something called hoisting, where the functions get hoisted to the top, and so you can call on them before you've defined them. Unlike in ES6, where you have to have them defined before you can call them. Takia, great question, Winder. Well, okay, so Takia is asking about the time complexity of this and how that compares to if you pushed every single element into an array and then added it up with reduced. So the time complexity changes, sort of. I mean, the time complexity of this is like n minus start, right? So m minus n, I guess. And then if we were to push everything into an array, it's kind of a negative experience because our space complexity also grows, right? This is constant space. We never have to use anything. We're always just using one extra variable to keep track of memory. If we have an array, we have to keep track of the whole end minus start memory. And then it's the same time complexity again. You wouldn't want to do it that way because of the space and because it's just a lot of unnecessary steps. It's not succinct. But that's a great question. Okay, I will figure out the math one after this, but let's keep going to do our practice. And so that is, I want you to write a function that takes in an array and returns the sum of all the numbers in the array, and I want your implementation to include for each. I know, I'm controlling your implementation. It's annoying, but it's part of learning. Good? Questions? All right, you have 10 minutes till 10:33. Yes. It's just the sum of all of them. I see what you're saying. Yeah. So, you had 1 minute. In my eyes, you're late, and I've made a note. So if you leave 2 minutes early, you'll be late.
Or
Everyone from now on is late. Okay. There you go. Before you're done, you consider one subsection. One. So, it's only a subsection. The array. You know, like it's almost like a blank space.
no.
It's just an empty array. It doesn't have anything in it. It doesn't have a space in it. It's literally not. That's an interesting way to think about it.
Oh, I'm like, did I just like completely wrap it up? Like, no worries.
All right, clap your hands if you can hear my voice. Awesome. Jonathan, this is the math solution. You can look at it later. I'll post the notes. Okay, so we were asked to do this problem with for each, and how'd this one go? Yes? No? Maybe so. Yeah, so we got a lot more of a drop off from the last one. Believe it or not, this problem is essentially the same thing, but instead of iterating through two numbers from one number to another number, we're just iterating through an array. For each is a method that we have available to us on only arrays, right? So if we want to go through an array, then we can use for each. If we're looping from one number to another, we can't. We have to use a for loop. If we're looping through an array, we can use for each. So let's get through this. Let's try it again. So let's say function, I'll call it somebody. And this took in an array. So just like in our previous one, where we had, this was our loop, right? Where we were getting each number. I hate that happens. We have to do kind of mostly the same things, a minor change. So the first thing we have to do is create this variable, because we're going to put out a number, right? That's the goal. We're taking in an array and we're outputting a number. Yes? Okay, so we're going to say let output is 0. Because we're going to be adding again, and anything plus 0 is anything. So, okay, so now the directions kind of told us how to do it a little bit. So we know we got to use for each. We can only use for each on an array. And we have an array given to us, so we must have to call for each on that array. Array.forEach. And now we got to think what for each does. Well, for each goes through and gives us every element. It can also give us an index if we want to. It's optional. But it gives us every single element, and it's going to call some sort of function or do something with every single element. This is essentially the inside of a for loop. So I go, okay, I'm going to take, this is going to be an element. We're going to do fat arrow. And just like for the for loop, the for each loop is all about the side effects. It doesn't return anything, right? So we have to capture its side effects in this output. So we know that each element is the element in the array. That's just how for each works. And so we say, all right, output plus or equals the element. The same kind of code as up here, right, where we did total plus or equals I, because I was the number. But this time, since we're adding all of the elements in an array, the element is the number. And that's what for each does. So it's going to loop through it, and with every element in this array, it's going to take that element in as an argument in this function. It's going to add that element to our output. And that's it. And then down here, we have to return. Return output. So let's try it. We go sum2. And we go, oh yeah, thank you. I just wanted to hear everybody yell that. 1, 2, 3, we should get 6. Booyakasha! All right, we got it. Questions on how this is working? What's for each doing? Jonathan. With each element. Yeah, exactly. So Jonathan says we're going through each element in the array and using this anonymous function with that element being passed in as an argument. That's it. It's not doing too much. Okay, so let's try it this time, something a little bit different. This is with map. Now, unlike for each or a for loop, where those don't have any kind of return value. When we use for each, it just returns undefined, right? We're only using it for that side effect. In this one, our side effect was changing the value of output. And we had to return output at the end, otherwise we don't have anything. For this next one, when we use map or any of the other ones, they do have a return. And so when we use map, map ends up returning an array. So for this one, I want you to write a function that takes in an array and a number. The output should be an array with every number multiplied by that given number. And I want your implementation to include map. So what's that look like? I'm going to say, I'm going to call it something it. I don't know. You can call it a better name. And I do like 1, 2, 3, and I pass in 4 or 4. My output will look like 4, 8, 12. I only go up to 3. Yeah. Okay. Questions? All right. So we've got another 10 minutes on this one. Rock and roll. Yeah, I want you to use map. I'm trying to control what people use, so they have to get better at it.
Yeah, I was like, I don't think so. No, you're fine. You good. You good. Yes. Oh, okay. No, yes. Yeah. Yeah.
All right, let's figure this one out together. Clap once if you can hear my voice. Clap twice if you can hear my voice. All right, so some of us really struggled on this one, right? This is a little bit harder. Why? The question is, why are we struggling on it? Well, it's because we don't seem to understand what map does at all. And so we are going to talk about it. Okay, great. So let me make an array. And I go 1, 2, 3. And I do dot map. Now, what does map take in as an argument? Not winter. What did you say, Trent? Callback, right. So this takes in a callback, and a callback is what? What's a callback? What's a callback in general? Yeah, right, Crispina, great job. It's a function that's used as an argument, right? It's just a function. That's all it is. And it's a function that gets called on every single element in the array, just like for each, right? Now, the only difference is that what map does under the hood, which we've seen because we've written map a few times, is that it stores all of those results from that callback and puts it into a new array. And then at the very end, it returns that array. So what's that mean for us? So we start to write something like element, because this is an anonymous function that I'm writing right now. It's just a function. And this function needs to have a return statement because I would care about this function's return value. Unlike for each, where I'm using it for side effects, for map, I actually care. So let's say I wanted to just multiply all of my elements by 2. I could do return element times 2. So what does this chunk return? 246. Right, and I can change things. I can make this, I could do plus 2. And I'm going to get 345. Right, this is just a function. If I wanted to do a function out here, I could say function add 2. And this is going to take in a number, or I'll say element, just to really drive it home. And then I would return element plus 2. Do these look similar to us? Do they look like identical? Here, I can make it. I mean, I can make it more identical. I can go const add. Okay, we're getting even closer. So basically, did I do something wrong? Yeah. Right. So from here over, it literally is identical because this is the function. And just this time I've named it. This one's anonymous. This one has a name of add2. Map takes in a callback function, which is really just a function. So I can do add2. I get the same thing. I have that return statement here because I need to return something from this function call. Questions so far? I'm sure some of us have got some questions. It's perfect. Oh, perfect. Monteza.
That's why we should return my map.
Why do we need to return in my map? So let's pretend I didn't have a return function here. And I called it. This function, add2, has no return statement.
No, what I'm asking is when you use .map function, I had some kind of idea that it returned by itself, that function, or map.
So it evaluates into an array.
Yeah.
When we call whenever we call map, as we can see even right here where it's undefined, 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 we still have an array. Whenever we're using .map, whatever comes back is going to be an array. So we don't necessarily have to return, if you're talking about putting a return here, potentially. But we do need our callback function to have a return because when we call this function, this has to have a return. Because if we remember under the hood, it's a for loop that iterates through an array, and it says like this at I, callback, this at I, and then whatever that evaluates to, we push into output, and that's what we returned at the end. So for this, we still got to put our return here so that we know what's going on. But we can see that when we just do .map on something, it evaluates to a new array. Any questions on that? Okay. So now if we move on to solving the problem, what do we name it? Did we have a better name for this than what mine named it? Multiply? Okay, I'm into that. So if we have this function called multiply that takes in an array and a number, and we're told we have to use my map, right? Or just map. So I know I only have, so I have to think. I got my input, I have an array available to me, and I have a number that I apparently want to multiply with to each element of said array, right? And I know my output is going to be that array where each element has been multiplied. So I go, okay, sounds like a good problem for map. Also, it was required. So probably is a good problem for map, definitely. So we're gonna look, we're gonna go array. The only thing we have available to call map on, and we can say map. Now we have to pass in the callback function, right? But we don't need a named function like I did here. And it's actually way more standard to just pass in an anonymous function. So I'm gonna go, all right, this is going to have an element. And then on this element, I need to return the element times the number. Are we with me so far? Okay. So, knowing what we know from here, what is this going to be? What is this going to become? What?
Does map returns an array?
Yeah. So Crispina says this whole section is going to become an array because that's what map does. Map gives back an array. We use map and we get this new array with the values that were from each callback call with each element passed in. So this must be an array. So what array is this? That's the next question we got to think. It's like, well, this is going to have every element multiplied by the number. So this is going to be the array we want to give back. So we can go, well, if that's the array I want to give back, well then, heck, I'm going to return it. Because that's where the array is going to be. I could also do what Winter did, and she said, like, let answer, and she set it to a variable. Because, like, all right, this is going to become an array. I'm going to assign answer to this, and I'm going to go, all right, well, I can return answer. Totally acceptable also. You don't have to. You could just return straight. But if this is like more clear and demonstrates even more that this section is becoming an array, well then that's a-okay with me. So let's try it. So let's call multiply with an array of 1, 2, 3. Let's pass in 4. And we get 4A12. Looks pretty good. Questions? I know we're not asking questions, but if I give you like the same problem tomorrow, I feel like we're gonna still have difficulty. So I feel like we definitely have some questions, and there's really no need to be shy. It's gonna be fine. If you don't ask questions, I expect us to all know it perfectly. Mateo.
No, personally, maybe it's not always questions. Maybe it's just like so, like maybe sometimes I'll forget to return to my math statement, or maybe I'll forget, whatever.
So that's fair. Yeah, that's fair. Crispina.
So the other way, you said that this was the way that Winter did, and the other way you said you would do return before the array.map.
Yeah.
You're saying that we can do that because everything after return there is literally the array, so we're just returning.
Exactly. So Crispina's saying she wanted to check in about why we can return here, and she's saying that we can return here instead of just set the result here to a variable because we don't actually have to alter or change that variable after we've already assigned it. So we can just return it right here because all of this that's highlighted is going to evaluate to the array that we want. So we can just return it. Boom, right off the bat. So just on a note to what Mateo's saying, you know, if we don't have questions and it makes all like total sense, that's great. And if the issue is that it's hard to remember, then that's an issue of practice. That's an issue, that's on you. You gotta go home and you gotta write map 200 times, literally, until it's not an issue of memory and practice. If you understand it, that's all the hard work. The rest is just how many times you can write it with your hand. Johnny?
Can you constant live or see that?
Like the,
A line between line way too.
so, but we're not hitting that line anymore. Do you want me to go back?
To uncommon line.
Yeah, this is, do you not want me to return here?
So then, between line three, constant live rate,
Which line do you want me to?
39.
So that would be as if we just called the function, so nothing will have happened yet. But what do you want me to console out?
I just wanted to see that the setup makes it harder.
So I can do that here. How about? Watch. If I go to our call and I say let R equals 1, 2, 3. That's an R. I didn't console log this. There you go. So yeah, map is a non-mutating method. I think that's what you were getting at, right? Yeah. So we can see that we can declare our array at the top. We can call a function that uses map on this array, and after that whole call, we can still look at our array and we can see that it's still the same old array that we've always known and loved. It doesn't change. It doesn't go off to college and change its personality and decides they don't want to be with you anymore because you're still just in high school. It's the same old array. All right? Are we good? All right, so I'm glad you understand it. Definitely keep practicing. So for the rest of the day, oh, not the day, until lunch, pair up and you'll be doing whiteboarding. So go to the like the DSA web area and choose questions that are within what we know. We know our stacks, we know arrays, we know strings, we know logic, we know integers. We know all of them essentially except for linked lists that are on that section. Okay, so find a pair, do that. And remember, real quick, let's just refresh. One person's interviewing, the other person's an interviewee. The interviewer asks the question, they read the question. The interviewee doesn't get to read or look at the question. Not how the game works. We have to stay in character. You want to talk about your inputs, your outputs, ask questions, think about edge cases, and then create a map of what you want to do. Maybe pseudocode or map, something like that. And then at the very end, after everything is logically thought out and understood, that's when you write the code. Writing the actual code for the problem should be very short, essentially, because all of the hard work should be done. Mateo.
And which one?
It's like up to you, anything. Probably not linked lists. Yeah. But the rest, I think we've learned. Good. Any questions on the whiteboarding and like the order of how to do it? Nope. All right, we're a quiet group. Let's go.
recording.